Welcome to our channel, my dear students. Today we are going to discuss about the previous year, that is last 10 year CBSE board chemistry questions part 13, in which we are going to discuss about the alcohols, phenols and ethers chapter. So here the first question is, describe the following with an example in which the Kolbe's reaction they are giving. So Kolbe's reaction, when it has come to my mind, so I had to start my starting material. I'll be using phenol as a starting material. If phenol, if it is react with aqueous NaOH, at that time it will form sodium phenoxide as a product. When sodium phenoxide involving in reaction with the carbon dioxide, at that time it forms these kind of product. So what I'm getting is ONA along with COO minus I'll be getting. So if I'm hydrolyzing this while with the help of acid, so I'll be getting a product like this. So this is my product. So here OH and here it is COOH. So here I'm getting salicylic acid. Salicylic acid. This is my product. Okay, that's all about the first reaction, that is a Kolbe's reaction. When it is react with aqueous KOH, which forms sodium phenoxide, when sodium phenoxide will react with carbon dioxide to form its respective ion, after that it will be acidified. Once it is acidified, it forms respective phenolic compounds like a salicylic acid it forms. The next one is, propanol has higher boiling point than butane. Why? Because propanol, so here 3 carbon atoms, 1, 2, 3. So propanol, they are not mentioning the numbers. So first position we have propanol is there. And butane, young butane, how many carbon atoms? 1, 2, 3, 4. Butane is there. Okay. So here, if in the case of propanol, say for example, if I am filling with H2 and H3. Here also H3, H2, CH2, CH3. So when boiling point come to my mind, so I have to fix the boiling point is directly proportional to molar mass. Molar mass. And the boiling point is inversely proportional to branching. Okay, there are two different concepts. One is, once the boiling point will be very high if the molar mass of the compound is very high, and boiling point will be very less if the branching is more. In this case, both are straight chain compounds. There is no branching, so that we don't want to see this. And the boiling point is directly proportional to molar mass. First we have to see the molar mass of the compound. C4, there is a C3. How many carbon atoms? C3. 3, 5, 7, 8. H8 and O. This is the name of the propanol. This is the compound number 1. Here also compound number 1. This is compound number 1. Here compound number 1. And compound number 2, what about that? 1, 2, 3, 4. 4 carbon atoms. C4 and H10. Now we have to see the molecular mass. C3 for the carbon atom, carbon it is 12, hydrogen it is 1, for oxygen it is 16. So I have 3 carbon atoms, so 36 plus 8 hydrogen, 36 plus 8 44 plus 1 16, 60 gram per mole. Gram per mole, that is a molar mass. But in the case of C4H10, what about that? 48 plus 10, 58 grams, gram per mole. Now what happened? So here according to molar mass, this will be having higher molecular mass. That's what it has, higher boiling point. That's the first reason. And second reason, here it forms the hydrogen bonding. Because of the presence of OH group, it forms hydrogen bonding. But in the case of butane, and butane, it has only weak van der Waals force of attraction. Weak van der Waals forces of attraction. Are you able to understand? weak van der Waals force of attraction. If you don't know about that hydrogen bonding and weak van der Waals forces, please go and watch my previous video. You will get a good idea about this in intermolecular forces. And here hydrogen bonding, it is a very strong one when compared to weak van der Waals forces, because if suppose one more alcoholic group is there, that hydrogen and oxygen will have an interaction. By the way, it will be very strong, it forms a very strong bond. That is what that has a higher boiling point. This boiling point according to molar mass also will be very high, and hydrogen bonding also very high. It has higher boiling point than butane. And why do phenols not give protonation reaction readily? So before we start, we have to write the structure of phenol. So I'll be start writing the structure of phenol. Here it is O, here it is H. Okay, now we have the lone pair of electron in oxygen. Okay, so now this is nothing but the phenyl group is nothing but this is a phenyl group. Okay, that phenyl group is nothing but it is a electron with a drawing group. So which will pulls the electrons of oxygen, which will not allow the electron density on oxygen atom in OH group. That is what it does not takes place, does not allow to protonation reaction readily, because the electron density will not be maintained here. That is what the protonation reaction will not be occur very easily. And next one is fourth question, that is write the main product formed in the following reaction. Here also the same thing. Suppose if I am taking a phenol, so I will be getting a product like this. My product, entire product is, this is the ultimate product, here OH and COOH. Here also I will be getting salicylic acid only. So here, so in presence of, suppose if I am taking a phenol, so this is a structure of phenol in aqueous KOH or NaOH, I will be getting sodium phenoxide, ONA. So if it is react with our CO2 followed by H plus acidification, I will be getting a product like this. This is my ultimate product, OH and COOH. This is nothing but salicylic acid. Are you able to understand, students? And next one is explain the mechanism of dehydration steps of ethanol. So we have to use ethanol. So CH3 CH2 OH. This is the ethanol. So which will involving in the dehydration reaction in presence of, that is nothing but the removal of water in presence of, what is that, H plus. So not to be water, H plus. So here it has lone pair of electron. It gives the lone pair of electron by the way CH3 CH2. Here it is O is there and H is there. One more new H is coming here. Because of donation of electron, it got positive charge. Because it donates 2 electrons, so that it got positive charge. Now, this is not a stable one, so that it removes as water molecule. Are you able to understand? So there will be a removal of water molecule, which will be called as, otherwise called as dehydration. So now what happened? CH3, CH2 and plus is there. Are you able to understand? Because of this bond is getting break. It wants to move as neutral, so that it gives negative charge. So negative charge, positive neutralized, will get positive charge. Okay, bond is getting break. That's what one positive and negative charge is getting created. Now this will be there. Now I will be writing this reaction product like this, intermediate CH2H and one more thing CH2 plus. Now the H plus wants to move on its own because to attain a stable product. If H plus moves, it leaves its negative charge, because this negative charge and positive charge, these negative charge and these positive charge will form a double bond here. So I will be getting a product like this, CH2 double bond CH2. This is a dehydration step of ethanol. Once it is dehydrated, it forms alkene as a product. Are you able to understand? And next question is, how do you convert? This question was asked in the year of 2015. Propene to propan to all. Propene, first of all, you have to write the structure. CH3, CH, double bond, CH2. Because 3 carbon atoms. In first question we have ene. That is what they are not giving prop1ene. So propene or otherwise called as prop1ene. So I will be getting propene. So propene, which will be converted into propan to all. Propan-2-ol, what will be the propan-2-ol? CH3, CHOH and CH3. This is a propan-2-ol. How can we convert this? So here is nothing but if these propene, if it is react with aqueous KOH or aqueous KOH, if it is react with aqueous KOH, what happen? Or if it is react with water, H2O, what happen now? H plus and OH minus. What happen now? Here, according to Markovnikov rule. Why we have to follow the Markovnikov rule? Because here the alkene is unsymmetrical alkene. If unsymmetrical alkene is there at the time, so the negative entity will go and approach where the lesser number of hydrogen present between the double bonded carbon. So here this carbon having one hydrogen, this carbon having two hydrogen atoms. So that is what the negative entity will go and approach where the lesser number of hydrogen atom present here. That is what I'll be getting a product CH3, CH, here it is OH, and if the bond is getting break like this get negative charge, by that way this got positive charge. So the negative entity will approach positive, the positive entity will approach negative. By that way I'll be getting a product propan-2-ol. Are you able to understand? And next one is benzyl chloride to benzyl alcohol. Benzyl chloride, what is the structure of benzyl chloride? Here it is CH2Cl. Are you able to understand? And if it is react with aqueous NaOH, what happen now? So this will OH minus will act as a strong nucleophile. This will go and attack the carbon. By that way it eliminate the Cl. So I will be getting a product. What is the product? So here it is, there is no change in bond, CH2OH. This is benzyl chloride, this is benzyl alcohol. Are you able to understand, students? So here, thank you so much for watching. Please go forward to others to get benefit. Please don't forget to subscribe my channel. Thank you so much for watching. Thank you.